All right, let's talk about two of the biggest buzzwords in tech, quantum and AI. You usually hear about them in separate corners, right, as these two massive, independent revolutions. But today, we're going to dive into their surprisingly interconnected story. And it's a partnership where the real action, the most important work, is happening in a place you might not expect at all.
So, you see the headlines everywhere. It's the big flashy question. Are quantum computers going to give AI this unbelievable sci-fi level boost? Will they unlock things we can barely even imagine today? It's an awesome idea, for sure. But the real story, well, it's way more nuanced and honestly, a lot cooler. So first, let's start with the vision that gets everybody so excited. The dream. The idea that quantum computers are going to fundamentally rewrite the rules for artificial intelligence. Okay, to really get this, think of it like this. Imagine quantum computing is a prodigy race car driver. This driver has almost supernatural reflexes, an intuitive feel for the track, just raw, unbelievable potential to be the greatest of all time. But here's the thing, potential alone doesn't win you the championship. And here is why people are so hyped. In theory, that quantum driver has some truly unique skills. It could just blaze through certain kinds of super complex math problems, handle incredibly sophisticated sampling for generative AI, and solve these mind-bending optimization puzzles that totally bog down our normal computers. You know, these are the theoretical racetracks where everyone expects quantum to just leave everything else in the dust. So, if the potential is that huge, what's the holdup? Why aren't we living in this quantum-powered AI future right now? Well, this is where our story hits its first big speed bump. It's time for a reality check. You see, right now, we're living in what's called the NIQ era. It stands for Noisy Intermediate Scale Quantum. So let's go back to our analogy. We've got our brilliant driver, but the car they're in, it's a prototype. It is incredibly powerful, a real beast, but it's also finicky, super sensitive, and prone to making mistakes. It hasn't been fully tuned for the race yet. Every tiny vibration, every little bit of noise can throw the whole thing off course. And this gap between the promise and today's reality is, well, it's pretty stark. The promise was this broad AI acceleration for everyone. The reality? We're seeing some limited, very specific speedups, but mostly in lab settings. Instead of some revolutionary new AI models, we've got these hybrid classical quantum approaches. And any talk of mainstream impact comes with these huge caveats about whether any of this can actually scale. And really, the bottom line couldn't be clearer. When you talk about the mainstream deep learning that powers the AI we all use every single day, quantum just hasn't moved the needle. Not yet, anyway. So does that mean it's all just hype? That we should just pack it in? No, not at all. Not even close. Because this is where the story completely flips on its head. We've been looking at how quantum can help AI, but the truly game-changing story right now is actually flowing the other way around. Okay, so if quantum is our prodigy driver stuck with a prototype car, well, AI is the world-class engineering team in the pit lane. It's the team that's meticulously tuning the engine, calibrating every system, and trying to turn that noisy, finicky machine into a real championship winner. And this isn't just a nice metaphor. It's happening in three really concrete ways. First, AI is learning to listen to all that noise in today's quantum hardware, figuring out what it is, and then filtering it out so we can get a much clearer signal. Second, it's helping us crack the code on quantum error correction, which is like the holy grail for building truly fault-tolerant quantum computers. And third, AI is acting like a brilliant software engineer, finding clever ways to rewrite quantum programs so they run way more efficiently and with fewer errors. And I really have to stress this. This is not some theoretical, maybe someday kind of thing. Nope, this is happening right now. The biggest hardware developers are literally baking these AI-driven improvements into their official roadmaps. AI's contribution is real, it's being benchmarked, and it's absolutely essential to making quantum computing work at scale. So what we have here isn't a one-way street. It's not just quantum for AI. What we're actually looking at is a deep symbiotic relationship. It's a frontier where each of these fields is actively pushing the other one forward. Let's bring our analogy home one last time. That dream of our quantum driver winning every race and shattering every record, it's still out there. It's still the goal. But, and this is the key, for that to ever happen, the AI engineering team has to perfect the car first. The
quantum for AI dream is completely dependent on the AI for quantum reality of today.
Okay, so let's boil it all down. Let's put it all together. What is the actual, tangible impact of this partnership? Right here, right now. It's simple, really. The impact of quantum on AI is still exploratory and pretty niche. It's fascinating research, don't get me wrong, but it's not changing the game for mainstream AI yet. But the impact of AI on quantum, that is already operationally important. It is actively making today's quantum hardware better and faster, and it's clearing the path to that fault-tolerant future everyone is racing towards. And that leaves us with one final thought to chew on. We started this whole thing by asking if quantum will supercharge AI. But maybe that's not the most important question we should be asking today. The real question, the one that truly defines this entire frontier, is this. How much AI will it take to first build the quantum computer that can finally deliver on that incredible promise? That's the challenge, and that's the opportunity.